Am I live now? Just checking that everything is working properly. I had an issue yesterday with that I didn't get any alerts when people sent me things in the... Looks like everything is good. Yeah, great. We had issues with like the notification not showing up, so I couldn't hear anything. Just listening sound. Yeah, cool. The goal for today, I think I have it in a to-do. No, it's not this one, it's this one. I think I will continue with the... I just checked, wait a second, is restream on... do I have a TTS or not? I prefer to have TTS until someone comments that they don't like it. And then I will remove it. Oh, shit, sorry. Where notification? Yeah, I have it. Or maybe I actually should keep it without, to be fair. I might actually do that from now on. But at least I should get a notification that we're doing things. Let's see. Firstly, we can start with, have I done today's problem? Yep. When is the new one? It's in 4 hours, yeah. So I did it yesterday. Yeah, the goal for today is to just learn linked list properly and from the ground up, because I realized I'm on a journey to like relearn all of the basic things, and I'm working through it slowly, just like I have time to digest everything I learned. And even I just did it briefly yesterday, and even that I learned so much about linked lists that I wasn't aware of. For instance, that I never thought how it was saved in memory, which is like which is randomly, and however you can assign pointers to each other. So in like it's not the same way that we see it, like the human way of seeing, like, oh, this linked It's more, yeah, like computer has its own system, which I wasn't aware of. So one of the questions I think was finding the intersection of two linked lists, and I couldn't understand why it wasn't earlier in node, since the value was the same, but that was the reason. And regardless, I think I will go to doubly linked list. I won't assume like it's anything special about it, so I think I'm just gonna oh shit. What is happening? Just like a quick introduction, I would assume it's exactly the same, just that they have a prev instead of let me see which one looks great. This looks good. But instead of just having a next.
The best way to learn math and science. It's brilliant, that org.
Hello everyone. In our lessons in this series so
format?
far, we have discussed linked list quite a bit. We have seen how we can create a linked list and how we can perform various operations with linked list. Linked lists, as we know, are collections of entities that we call nodes.
I have to have it done double speed, unless I'm not able to learn anything.
Data, and another to store address of the next node. Let's say we have a linked list of integers here, so I'll fill in some values in data field of each node. Let's assume that these nodes are at addresses 200, 250, and 350 respectively. I'll also fill in the address field in each node. The address field in first node will be the address of second node, which is 250. The address field in second node will be address of third node, which is 350, and address part in third node will be 0 or null. The identity of a linked list that we always keep with us is the address of head node or reference to head node. Let's say we have a variable named head only to store the address of the head node. Remember, this variable named head is only a pointer to the head node. Ideally, we should have named this something like head pointer. It's only pointing to the head node, it's not the head node itself. Head node is this guy, the first node in the linked list. Okay, so right now, in the linked list that we're showing here, each node has only one link, a link to the next node. In a real program, node for the linked list that I'm showing here will be defined like this. This is how we have defined node so far.
To be fair, I think that's an actually interesting distinction, that the head is just a pointer, which points to these elements.
Lessons, we have two fields here, one of type integer to store data and another.
And
of
not
type
like, yeah, not just like,
a pointer to node, struct node asterisk. I'm calling this field next. When we say linked list, by default we mean such a list that we can also call singly linked list. What we have here is a singly linked list. What we want to talk about in this lesson is idea of a doubly linked list. The idea of a doubly linked list is really simple. In a doubly linked list, each node would have two links, one to the next node and another to the previous node.
yeah.
Programmatically, this is how we will define node for a doubly linked list in C or C++. I have one more field here, which once again is a pointer to node, so I can store the address of a node. I can point to a node using this field, and this field will be used to store the address of a previous node. In a logical representation, I will draw my node like this now. I have one field to store data, one to store address of previous node, and one to store address of next node. Let's say I want to create a doubly linked list
Yeah,
of
like,
integers.
are there
Let's say
any
these are
more
nodes,
about
which is
it?
400, 600, and 800 respectively. I'll fill in some data. Let's say the cell in the middle in each node is to store data. The rightmost cell is, let's say, to store the address of the next node. So for first node, this field will be 600, which means we have a link like this. For second node, this field will be 800. For third node, this field will be 0. For first node, there is no previous node, so this leftmost cell, which is supposed to contain the address of the previous node, will be 0 or null. The previous node for second node will be 400, and the previous node for the third node is the node at address 600. And of course, we will have a variable to store the address of the head node. Okay, so what we have here is a doubly linked list of integers with 3 nodes. Okay, so with this much, you already know doubly linked list. If you have ever implemented a singly linked list, then it should not be very difficult implementing a doubly linked list. One obvious question would be, why would we ever want to create a doubly linked list? What are the advantages or use cases of a doubly linked list? First advantage is that now if we have a pointer to any node, then we can do a forward as well as reverse lookup. With just one pointer, we can look at the current node, the next node, as well as the previous node. I'm showing a pointer named temp here. If temp is a pointer pointing to a node, then temp.next is a pointer pointing to the next node. It's the address of the next node, and temp.previous, or rather temp arrow previous. This is actually a syntactical sugar for asterisk temp.prev. So this guy temp arrow prev is previous node, or in pure words, pointer to previous node. The value stored in temp for this example right now is 600, temp.next is 800, and temp.prev is 400. In a singly linked list, there is no way you can look at the previous node with just one pointer. You will have to use an extra pointer to keep track of the previous node. In a lot of scenarios, the ability to look at the previous node makes our life easier. Even implementation of some of the operations, like deletion, becomes a lot easier. In a singly linked list, to delete a node, you would need 2 pointers, one to the node to be deleted, and one to the previous node. But in a doubly linked list, we can do so using only one pointer, the pointer to the node to be deleted. All in all, this ability that we can do a reverse lookup in the linked list is really useful. We can flow through the linked list in both directions. Disadvantage of doubly linked list is that we're having to use extra memory for pointer to previous node.
Okay,
For a
yeah.
linked list of integers, let's say integer takes 4 bytes in a typical architecture, and pointer also takes 4 bytes, pointer variable also takes 4 bytes. Then in a singly linked list, each node will be 8 bytes, 4 for data and 4 for link to the next node. In a doubly linked list, each node will be 12 bytes. We will take 4 bytes for data and 8 bytes for links. For a linked list of integers, we will take twice for links than data. With a doubly linked list, we also need to be more careful while resetting links, while inserting or deleting. We need to reset a couple of more links than a singly linked list, and so we are more prone to errors. We will implement doubly linked list in a C program in next lesson. We will write basic operations like traversal, insertion, and deletion. This is it for this lesson.
Yeah, pretty innocent enough. I'm just gonna check if I've done like the previous. Yeah. I think I am comfortable enough to just. Oh, design. Okay, design your implementation of a linked list. You can choose to use singly or double linked. A node is singly should have 2 values, the value of the current node, and next is the pointer reference. If you want to use the double linked list, you need one more attribute. Would this be a dictionary, or is it actually just indexed? Get the value of the index. I feel this is more or less describing add at 10 and not before the first element of the linked list. After inserting, you will be the first node of the linked list. Append a node of value at the last. Yeah, because that add a node of value. How would I do it the simplest way? what is a node by itself? Just checking. Fuck, I need to close this. Oh, I turn off Discord again. Shit. Sorry, Solaris. But once again, I didn't get the notification, so I don't understand why. Shouldn't this like give me... Like, I have enabled desktop notifications, so I don't understand why. I closed Discord yesterday. Why is it so slow? Yeah, okay. What the fuck? No, but it's on. Now I actually heard you. Yeah, I heard you now. So I think it was just because I had the option. I hadn't like saved it by like closing it. I will assume that's the problem. And I turned off Discord yesterday, but I don't. Why is Discord not opening up? Like I'm. You see, I clicked Discord right. It's not just me being dumb. Reasons? Shouldn't this like open Discord? Do I need to do Discord online? It's so... Okay, I can do it online. Yeah, I don't need this. Actually, his check was not the boolean, but the condition on which he could early return. That's so interesting because I had something like this in the beginning, but it didn't work. Like, if I don't think you watched my stream at that time, but before, while I was doing it, I had something like this. However, I got error. And when I watched his code again, I was like, oh yeah, apparently you need both. So it would be increasing. Or, yeah, it would be increasing, wouldn't it? I'll check it out. It's decreasing. Larger than M or... I still struggle to grasp like exactly what's happening here. Oh, because mine... Okay, Right. Because then you have two conditions that it's hard to understand. Yeah. Because I don't need to draw it again, but I had something that actually was similar to that, so it would be... But I realize I need to learn like specifically what does decreasing mean. I thought it was increasing. Because for binary search. Oh, I thought it would be false, true. Okay, so I understood it correctly. I just assumed it would be false, true. Okay, I understand. But like, just like confirm with you, Solaris, the requirements for using binary search is firstly that the list you're sorting by is monotonic, meaning it's strictly either increasing or decreasing, or equal to, yeah. Yeah, and that the truth, yeah. Because the issue with what we had like previously was that we get like false, 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 true, false, 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 by having both of them, if I'm not completely mistaken. If it's the first one, low changes in the if. If it's the second one, high changes in the if. Yeah. Which makes sense. I need to like think of like it. Obviously, it makes sense. You should basically either return the like depending on if it's increasing or decreasing, you always want to return the first instance or the last instance depending on if it's increasing or decreasing. So you keep the loop invariants. Well, could you explain what the loop invariants are? I'm not familiar with the term. Is it like the low and high? Google that, okay. Okay, I think I understood it. Just to ensure I understood it, I will make ChatGPT explain like I'm 5. Something which is always guaranteed before, during, and after the loop. Yeah. It's like a promise the loop keeps every time it goes wrong. Yeah. There will be, for example, Lou is oop or is false, and high is oop. I'm trying to figure out what oop means, if it's a significance or it's true. Out of bounds. Oop. Yeah, okay. Yeah, but I agree. Yeah. So you keep the loop invariance. Yeah. It will always... Out of bounds. I've never seen oop. That was kind of cute. Yeah. Like, I think like we had discussed this problem in depth enough that I do believe I understand it. I still am under the impression that I would never be able to solve this in an interview of 45 minutes. Like I wouldn't be able to solve it. I would probably explain it well enough that I will get like some good grades, but I wouldn't be able to implement it correctly. My issue is still I don't understand the check complete. I know what the check is doing. I'm just like unable to like instinctively know, like for instance, oh, J would be yeah, like the index and the outer bounds. I think I'm like this part. I think I would be able to I would probably write something wrong. But still, my point is essentially like in an interview situation, if something like this or like something similar like this, I would be able to like see what the steps would be, and I will try to explain the check. I just, because I understand the check like theoretically, I just struggle to implement it correctly. Because like I'm looking at it, this is like just a smart way of doing what the Leetcode thing was doing, from what I can gather. Yeah. And that's also my point, because I don't know, like, this is the standard of most coding interviews, at least the coding interviews I've been in. I don't code in like virtual environment or whatever. I code in fucking Google Docs or whatever. So I'm not even able to see if I do something wrong, but like if I explain it well enough, I think it's fine. The only times I like... Yeah, but my point is that in the interview, you don't necessarily decide the platform that you use. At least in my experience, they often have things like their own system, and often not, like I'm not able to code or see what it would return. Yeah, and that's why like this would be impossible for me, because I wouldn't be able to understand the cumbersome small things that would occur. Yeah, exactly. But and yeah, and to be fair, I don't think they would expect you to solve it either. I saw some of the comments on that specific task, and they told them like, "Oh, I'm a interviewer and loves to use this question," and no one has like solved it ever correctly, like on the first try. So I think it's fine. I think it's also, it could also show like you know the code well enough to, and like you don't need to be not necessarily dependent, but like at least when I code, especially in Leetcode, I like to see what it prints out. I do it like in all of my developing. Like if I have an issue with when I was working with front end, I would have console log and figure out, okay, is this actually returning the correct answer or is it not? Yeah, this was the one I was confused about. By the way, so Larry, I'm probably gonna cut this stream shorter today. I didn't sleep that well yesterday. I was woken up multiple times. So I probably couldn't, it would not be like the late night grind that you're used to from me. Just like, so you know. I feel this is so weird. No, no, I didn't want to check YouTube, I don't care. I didn't want to check YouTube, I don't care. I'm just annoyed that I don't get like... Oh, okay. I don't get notifications properly. Or maybe it was because I was just watching the chat, so obviously it wouldn't give me a notification. That might be the issue. Okay, then it's fine. Oh fuck, Pirate Software is on. I'm just gonna check him out really quick. Yeah, be right back. Fuck, he's not there anymore.
I have returned.
He has returned. Oh, but all is also on. Fuck, I love.
Yes, you're right. I should shoot the dealer. Dealer is dead. Okay, I think I'm supposed to shoot the gun, but this game is busted. Do I win? My mother is doing great. She's been consuming a healthy amount of human flesh recently, and we believe she's almost recovered. Filtered. Oh wait, am I supposed to keep track of the shots? Okay, let me actually...
Wait a
try
second,
to
is this
properly.
actually just an AI?
I don't know what the function being used is actually called because it isn't shoot like it should be.
Oh my fucking god, that's amazing.
I just shot the dealer with a live round. Wait, I forgot to actually keep track of shots. Was it 2 blanks and 2 live? Do you think the dealer will eventually run out of blanks? Filtered. Oh, sorry, I forgot to be focusing. I got distracted by how dumb you all are. None of you know how to actually play this game.
I would assume it would be multiple AIs that it's not just one singular AI, like a machine learning model. It's more like depending on what thing.
I'm a little rusty, but
I don't think it's just plugging. No, definitely not. Oh, you mean the conversation thing? To be fair, people have been really good at like actually creating, using ChatGPT API to like actually create personalities. And I've also seen some large language models that use
There are no monsters under my bed.
yeah, that they use ChatGPT as the base to create like live commenting.
You may want to sleep with the lights on. Should I use the beer or the handsaw? I think I just used the item, but I don't know what the function is called to shoot. I'd rather just shoot. I just shot. Was that not obvious?
Damn.
Can someone please tell me what the tool is called to actually shoot? Oh, I hate this game. Why is there not just a tool to shoot a... I've had enough of this.
Oh, it has different personalities?
Scream enough, the dealer will get scared.
Fuck yeah, this is awesome.
Womp womp. Did it work? I'm so sad. I really thought that would have worked. Oh well, I guess I'll...
Superbra tale. Nå kommer de til å følge etter oss som en flokk med får. Dumme som sauer. Han tror kanskje jeg er født i går, han der. Eller hva, karer? Red Bull gir deg vinger. Slow, lay down, suppressive lasers. Reloading.
What are you doing, man?
Reloading.
Reloading. What the heck are you doing, man?
really not in the mood right now. The shots are not randomized, that's a lie, it's just a skill issue. We've both shot twice. There should be 0 blanks left. Oh wait, I only have 1 health left. Should I be scared? I don't need to be scared, because no matter how much health I have, I'm still equal.
That's awesome.
Should I feel threatened by the fact there's twice as many?
I'm just trying to decipher, like, because I don't know how VTuber works, like how it's created. So that might be something I'm uncertain about. However...
Oh wait, I just realized I'm dead. It's over.
She can even
What
sing.
do you do when the tool doesn't work?
Okay.
Goodbye everyone, I've accepted my fate. It was nice knowing you all. I've tried
So they say
shooting like 23
for the
times
large
now, and
language
nothing has
models,
happened.
it's ChatGPT.
Even when all odds are against me, I still never give
I
up.
think it was 3 they
That's what
said.
it truly means
This
to
is
be
OpenAI
Do you think you're
API.
still safe? Think again. I'm coming for you.
which I will assume is like for creating the chat box and all the functionalities. There are extensions that I know that can make it sing. I don't remember what it's called, but like recently there have been a lot of like improvements to how that works, but at least it's an extension. For one is like the singing.
But I found out that he won against God. This might be harder than I thought.
Or this might be more separate, but I would assume it's the same. Slash voice. I will assume that it was the same slash that text to
Dealer has been
speech.
banned for 10 minutes. Now I can safely continue the game.
Mm-hmm.
Wait, NVM, it didn't work.
But what fascinated me is the AI, like gameplay.
What's even happening to this tool? Okay guys, the tool is clearly broken.
This I'm uncertain about because I know there are tools for this, I know there's tools for this, and also I'm not certain about the VTuber thing, like how that is created. It's just more that I don't know, understand what VTuber is.
Hi Closec 13. I keep
She
forgetting
can
to
play.
make you ask CI.
Yeah, I understood it started as Osu.
What's your Discord name?
No, the case is like, I don't think it's difficult necessarily. Like, take it with a grain of salt. I'm like, this is impressive.
Oh, right. One of my memories
What I'm
just
saying
reminded
is
me
like,
that I lost
it's
Nero earlier.
pretty
Should I be worried about that?
straightforward to create a specific AI for a specific game.
Time to end stream.
What is amazing me is that apparently they can play multiple games, and that's like, oh, this is different. I would assume it can only play a specific game still, like there's just a bigger roster,
You know,
but I'm not
shoot
certain.
myself more in this tool, but I'm afraid I can't after being told I shoot myself too much in these games. Something about clout chasing getting old or something. Okay, now let's actually play. Well, anyways,
This is fucking amazing, like honestly.
Betting the rats are back, they're always the problem. Rumor has it that they even reside within the tool. I can't remember. There we go, I just had to shoot the dealer.
React to videos. Oh damn, they also have what image recognition
Wait, I shouldn't kill the
thing.
dealer because I think he has neuro.
What is it called? It's like I had a course in it. I don't remember what it's called
Oh
now.
wait, I think I just
It's
placed neuro in
embarrassing.
my memory. Then I should be fine. Let's see. I'm pretty sure that's 2 blanks that have been shot now.
Damn.
What? There's still 2 live rounds. So the next 2 shots are live rounds.
I will actually read more. Like,
Focus now. Shoot me again.
return and I learn more about it.
Should I use the handsaw or just shoot?
Yeah, and it continues to upgrade it. This is fucking awesome.
Okay, I'm pretty sure that's 2 blanks in a row now. Easy. Okay, now that I'm
Yeah,
focused,
speech
let's
text.
end this. Why is the shoot tool still not found? They
Feed
were
messages
totally lying to
something
me
like
about the tool
ChatGPT
working
and get the
again.
output based around a character
I
you
mean, I
define
have
via
1 GP.
prompting.
Surely this next shot won't
Yeah,
end me.
that I assumed. Most of them use API, yeah,
Wait, is there a tool
which
for
essentially
magnifying
to
glass?
access, like, yeah.
Maybe I should check then.
This
I tried
range of,
searching,
okay,
but I just got
you
a
have
bunch
a
of guides
camera
that I
translate
can't
your
open
body
because
moving
it's
to
filtered.
values. You can
Filtered.
also direct adjust
Not
these
me.
values without motion capture, yeah.
Actually,
You can
no,
play
wait,
a
I
loop
remember what
for
that item
pre-made
is.
animation
It's
or
pretty
create strips to
self-explanatory
adjust
anyway.
these values for dynamic VTuber movements.
And there was only 1 live round remaining.
It's
Looks
the
like I
main.
won.
He created a
Skill
prominent
issue on
text
the
input
dealer's
from Twitch
part.
and voice and
Clear
gives the
AX
input
run
to
voice.
a large language model. Then gives the output to a TTS, which is what you hear when neural
Okay, cool. I'm
just
sick of this
evil
game.
speaks.
I just want to shoot some real people now.
An animation as well. it then becomes a matter of adding more features.
Yes,
It's
I'm
not
gonna
too
become the
complicated to
dealer.
have 2 AI or more running at once. Source of
I
idea.
am now the dealer. This stream is mine. Now who wants to shoot some real people? And I'm not talking about in Minecraft. The results were just the community guidelines and a harassment policy. They don't seem relevant, so I didn't read them.
Fucking awesome.
In all seriousness, we should go around taking out every rat until we find the dealers. That would solve everything. Play Among Us sus. Let's change topic. We're going to take out the rats, okay?
Cool.
Okay, back to the game. Let's
Yeah,
focus
okay,
again.
back to some... Are you still there, Solaris? No, I like, No, it's more just the fascination of... I don't know if I've talked about it, and this is by no means like comparing me to what the Dala done, because that's leagues ahead of me. But my specialization, for my master thesis, was artificial intelligence, specifically in large language models. So that's why like I got like, try to figure out like, how is this created? How is like everything connected? And yeah, it's just nice to look at it again. And I was just looking at the aspects that I could maybe have used in my own master thesis. My master thesis was AI generated. It's like an intersection between AI generated music, yeah, I'm not surprised. Like a lot of the best AI researchers and AI like YouTubers I've seen are self-taught. It's just like you need a burning passion for it. So yeah, so I know a lot of the theories behind it. I'm not as well as implementing it, and hopefully in the future I will work with something similar, like as an AI researcher or whatever. But right now I know I need to just start from the bottom of the totem pole in the tech industry, and that's why like I'm doing Leetcode. But yeah, that's awesome. Like it's not a bottom, but it's the Leetcode is so specific for software engineering, and software engineering is usually the bottom of the GCD, the greatest common divisor. Yeah. Yeah, it's the fucking GCD of tech. I was like, why the fuck did you say greatest common divisor? But yeah, you can say so. But it's not the bottom, it's the bottom of the best, if that makes sense. Because like, at least in Norway, the majority of, like, we don't have Leetcode in Norway basically. I've never done a Leetcode for an interview. The majority of the interview is more about system designs and case problems. Some few times there will be like really technical, what does an API mean, etc, etc. I dislike those. And so the easiest interviews I've had ever is like a personality test essentially. It's just like talking, like, oh, what do you do in your spare time? Oh, I do this. Cool, you want a job? Fuck yeah. But yeah, I like the way of seeing like the greatest common divisor. That's actually funny. Yeah, what was the... I get so easily distracted. Today I'm learning linked lists properly, like actually knowing the in and outs of them, because like I know them theoretically, but I noticed I struggled to like to visualize everything as I would do with, for instance, a list, normal list, or a stack, or queue. I would easier like visualize it in my mind. With a with a linked list, I sometimes like, oh, okay, what am I pointing to now? Have I skipped too far? How is the algorithm, the fast, slow algorithm, etc. It's not. I don't think linked lists are that important, but I remember having some few. Oh shit. Because I remember the fast slow pointer. It's essentially just finding either the middle or like there are different uses for it. However, I want to learn it properly. Because like I like the eloquence of the slow fast algorithm. It's not a complex thing to understand. It's pretty simple, and it's a great way to find cycles and also find the middle, etc. Yeah, stories on when here. I was never aware it's called the Floyd cycle detection algorithm. Damn, what the fuck? What, almost 90 minutes of this? Oh fuck. Yeah, I don't think that's like us. What was the Floyd cycle detection algorithm? Yeah, for the first repetition, it's great for the shortest cycle. Awesome. I love when you combine comedy with.
Set up CI/CD configurations.
Okay, no, dude, I love like I've seen some of these before. I like Jomatech.
With self-tuning pipelines.
It's fun.
Let's check it out real quick.
Alright, this is what I've been training for. I'm not gonna let Senpai down. What do we have here? Find duplicate number. Given an array nums containing n+1 integers, where each integer is between 1 and n inclusive, prove that at least one duplicate number must exist. Of course, because of the pigeonhole principle. Child's play. Assume that there is only one duplicate number, but it could be repeated more than once. Find the duplicate number. I got it. If the numbers are sorted, then any duplicate numbers will be adjacent in the sorted array. A simple sort and a linear scan will do. As expected, I knew it couldn't be that easy. But if you think that would stop me, then you underestimated me. I have no choice but to use my secret weapon. Hash map. The famous hash map, one of the most powerful data structures for reducing your time complexity, taking advantage of its
Okay, give me a second.
data structures.
This is actually gold. This is actually gold.
your time complexity, taking advantage of its constant lookup times. However, using a hash map requires me to increase my power level, so I need to wear these to suppress and control my powers in case it gets out of control. Also, my doctor told me to wear them to treat my carpal tunnel. Nani? Wait. This question is too strong. Too weak. I'm running out of ideas. I can't solve this medium problem. How can I even be a real engineer? How am I gonna get into Google? Kusa!
Seems like you need some help.
Senpai!
This question is trivial.
He's so cool. And it's
I had a professor who did that every single time. Like, it was my first year of uni, and we were dumb pieces of shit from high school. We don't know shit. And he was like, "Oh, this is trivial. Oh, this is elementary." And we were like, "We don't fucking know what you're talking about." Oh, so I hate that phrase. "Oh, this is trivial." Fuck.
It's so big.
Solving this in linear time and constant space requires Floyd's tortoise and hare, a simple cycle detection algorithm where one pointer traverses twice as fast as another, and once they meet, you can trace back to the point where the cycle began. In our case, the values of the array is like a pointer, pointing to indices of the array, which is like nodes in our case. Because each number is from 1 to n, then each value will have to point to a valid index, and since there's a duplicate number, there will be a cycle. Find that cycle, and you will have your answer.
Dude, I would
What are
never
you
have
waiting
solved
for?
it.
Pull it yourself. Senior engineers don't code anymore. Also, my doctor said not to, because of my carpal tunnel.
That works. Senpai, why are you so smart?
Because I'm a gangster.
Now I'm curious what part 2 would look like.
I'm finally here, interviewing for my dream job. After all the training I've done, I can't let this opportunity slip. Ever since I was in high school, I knew I wanted to be a software engineer. Oh, it works. This is so fun. If I keep this up, I'll be a staff engineer at Google in no time. And so I studied non-stop in college with my eyes set to becoming the next Jeff Dean. I knew it wouldn't be easy and I would have to get through many obstacles. I worked day and night, persevered through hardships with one goal in mind.
Hello? Hello, can you hear me? Is this still a good time? Oh, no worries. I might have been muted or something. Alright, let's get started. Just a little intro. My name is Nikhil. I work on the cloud team. I've been with the company around 3 years. Can you tell me a little about yourself and why you want to work for this company?
Yeah, because the only time I feel free in my life is when I code. I may not be the smartest person, and my whole life people have told me no, but coding was the only thing that accepted me. It welcomes anyone with open arms. No matter who you are or where you're from, all you need is a notepad and the world becomes your canvas. And just like how coding shined a light in my darkest days and allowed me to be more open to the world, I want to work here to help make the world become more open and connected.
Yeah, okay, sure. Let's move on to the coding question. Shouldn't take too long, and then we'll have some time after so you can ask me some questions. So the question is, given a binary tree, can you print the values out layout in an in-order fashion.
In order. Binary tree. My favorite. Binary trees. A data structure where each node has two.
Hello? Sorry, I think you cut off again.
Oh, I'm sorry. Yeah, I'm here. Okay, so yeah, so for that question, I will perform a simple recursive algorithm to go through the tree in an in-order fashion and print every node I visit.
Alright, excellent. Looks good. Now, the next part of the question. I want you to not use recursion for the same question. Can you do it iteratively?
Iterative. Iterativo. Masaka. How is that even possible? Wait, relax, think. Kuso. I ran out of flashbacks. No, I can't even pass this phone interview. Wait, I got it. I'll use silent keyboard. With my left hand, I can start typing nonsense on the shared codepad as comments, while my right hand will silently Google the answers on my iPad. And since there's no physical keyboard, it makes absolutely no sound. I've won.
Good. That looks good. And what is the time and space complexity of this?
Well, if n is the number of nodes in the tree, then the time complexity is O of n, and the space complexity is O of h, where h is the height of the tree. And in worst case scenario, in an unbalanced tree, the height of the tree is n. So O of n would be the worst case.
Alright, that's great. I don't think I have any more questions for you. Do you have any questions for me?
Yeah, so how do you become a staff engineer? Thanks for watching. I hope you enjoyed that. Sorry I haven't posted in a while. It's because I've been working on Joma Class, which is a subscription service to get.
Yeah, but it's nice to have a name to this. I always just call it slow fast algorithm. It's nice to have like, oh, Floyd's cycle detection algorithm, tortoise and hare. That's cool. That's cool. I got this notification at least. Kind of. What was this again? Oh, what? What up? Long time no see. I tried. Oh no, I know the. Oh fuck! I didn't see any of these. Yeah, agreed. Aren't you supposed to teach me, bro? You're the fucking 5 years of experience, motherfucker. What turns in if I start at the base is stick off the lollipop so you know that they will be easy. I couldn't stick because they're. Yeah, so why you're asking me? I started a week ago. You ask Solaris, his incredible Adam. Yeah, we can do some lead codes. Fair. But I will just say, like, inexperience doesn't mean good IQ either. I also love that you're using like the statements. But like I said, like I talked to Solaris about it earlier. Like in Norway, we don't do Leetcodes. Like no interviews has ever given me a Leetcode question. I think like if they did, people would get pissed at the company. Like, what the fuck are you doing? But I noticed like at least yeah, in France, but I noticed it's a big thing in at least India, United States, Canada, and I think maybe another country I can't remember. But I noticed like it's really big there. And generally the biggest companies also like value it. Don't ask me, I have no idea. So yeah, what was I supposed to do? Fucking my ADHD is taking over. I forgot what I was supposed to do now. Sure, I can tell you about my favorite techniques and topics to learn. Yeah, sure. Okay, just to respond to Axer quickly, I want to work in another country than Norway. That's the issue. And this is not talking down about Norway itself. I think it's wonderful. It's more just that I have worked in a lot of different different startups and internships in consultancy agencies, and I just think the level of innovation is too low. That it's more often. Yeah, but I don't think it's technical development. What Norway is great at is like renewable energy, a lot of maritime technologies. I think the biotech is also pretty good. I'm not certain about the last one, but I wouldn't say like specifically. Yeah, I wouldn't say like specifically that they're great at innovation in the computer science department, you could say. But I think it's more like no point moving to US. Dude, like, I know you're joking about it, but if I had a chance in Silicon Valley, I would fucking move there right now. Actually, we can switch places. No, what I want is essentially to just suffer. I want to suffer. It sounds fucking masochistic. But it's more that I want to go through a rough time, so to build up like experience the fastest way, and then I can live because like I want to it. Yeah, I imagine. And you've done this for like 5 years now? How long have you done this for? And like and that's something I'm prepared for. I know like the big companies will exploit the fuck out of me. And I'm willing to do it for 6 months. Okay. Because I'm willing to do it for a few years. Because of the student visa, bro. But yeah, I think I would be willing to do it for a few years. like I don't think I will end up there, like, to be fair, because like it's so difficult to even get there, and then the pressure. Yeah, I told him that's my point. Like, yeah. So like I'm not aiming for it. It's more like if I got a chance, of course I would go there. But that's not what I'm aiming for now. I'm probably looking in Europe. I think I just want to work and hopefully work towards somewhat of notoriety, meaning that I will have an established like resume that I can. Why don't you move over here then, Axor? You can move to France or Norway. Me and Solarius probably have like room in our basement. You're thinking of it, okay? I don't know like how the visa is for Indians to work in Europe. Yeah, we have a yeah, we have a king, and he's so sweet. Like there's just some debates like it's been ongoing forever, like whether we should be a because we are by definition a monarchy, but like I will not go too into details on Norway, but like yeah, we are a monarchy, and there are some discussions whether we should be a monarchy or not, etc. etc. And generally the king is well liked, from at least my experience. So yeah, we have a king, and he is the I don't know like what the term is. It's like I think he and Queen Elizabeth have the same great grandfather. I think. At least they are in they're connected. No. You like you can say shit about the king. Like no one. It's not like a dictatorship. No one cares about that. For me, the reason I don't talk shit about our king is just like he seems wonderful for us. But I'm talked to a lot of other people who has had kings that are really horrible, and that's why they're like really against king. But another case is that the Norwegian king don't have any real power. He's more a symbol than anything else. We have a prime minister, which is the one who actually is elected and by definition the leader of the country. So I think there are some formalities in case that the king can veto some laws in our parliament, but that power has never been used except from maybe like the Second World War. So yeah, it's more the symbol the king the royal family represented, and I know for a fact like a lot of people likes the king now, and a lot of people loves like the crown princess, I think it's called. Like it's the next king's daughter, which will be queen after his dad. I know like there's in media all the time, like people like talking well about her, and like I see, just like so people know, like I have met her. She lives like close. She lives like in the same not neighborhood, like same area as one of my friends. So I met her. I also met Prince. He attended one of our school trips, I think, and he was just like, "Hey, what's up, guys?" And we were like, "Hey, fuck yeah, the prince, yeah." You know about her? No, fuck, no, her, fuck, I was thinking about, no, that's daughter of the king. I was thinking about Princess Alexandra. Ingrid Alexandra. It's, I can, yeah, so, yeah, but back to the question, you want to pay off your education loan and then move to Greece or something. Shit, how expensive is it to get a like degree in the States if you're still there, Axor? Yeah, no, the son. We don't need to go that like into Norwegian news, but I believe like recently, the son of Martha Louise are in. I think it's trial. He. Yeah. But I'm more interested in like you have to pay off your education loans. How much is it like? Yeah, how much is it? But generally, I notice like when people talk about like Norway being a monarchy, like I talked to your elder while I was studying abroad. A lot of people like didn't like the fact that we were a monarchy, that Norway is a monarchy, and I understood it from their point of view because they historically they have had really bad history with like their royal family, with a lot of like scandals. While in Norway, I'm just thinking of like all this, if there are any. But like I said, it's a symbol. The royal family doesn't have any real power in the, like they can't impose laws, etc., etc. It's still. I love actor asking the real questions here. Yeah, like I like them. Yeah. Thanks for asking the important questions. So, do you want to move here? I think it's interesting because like when I talk to people, like, one of the first questions people ask is like, "Oh, how does the ladies look in Norway?" Like, yeah, no, they're beautiful in my opinion. I never like assumed I would talk about the what is it? I would never assume like I would talk about the monarchy or the attractiveness of women in Norway while doing a Leetcode stream, but who knows? It looks like this takes precedence. And to be fair, like I mentioned it earlier to Solarius, but I had slept really bad, so I'm gonna cut this stream short, and I just don't have the mental capacity to do like any difficult lead codes. I feel like now Asker and Solaris are just googling Norwegian women. Yeah, my man Solaris got it. Binary lifting, never heard about. Union fine, I will assume like it's the Venn diagram. And string hashing, is that like this thing you do with the order of x minus order of a? Okay, it's part of it. Okay. I think the smart thing I can do now is just firstly just write these down. Maybe it's easy. Solaris, do you want to join Discord? I will try to get Discord on. Because I assume it's easier to explain it talking than it's just writing everything down. Or I don't know what you like. Give me a second. Like I said, I don't know. You saw that I tried to open Discord on my PC. It's not working. Testing. Is the sound on?
Yeah, hello?
Yeah, great.
So, yeah, what do you want to learn about? Union find, binary lifting? What would be the easier to explain? Binary lifting is actually pretty straightforward. So you have a tree. Binary lifting is when you have a tree. So you have a tree. And you want to get the ancestor of any node in the tree in O of log n time. Or, yeah, O of log h time at most. Where h is the height of the tree. Well, actually, it will be O log the number of parents you have to get to you know.
I was gonna say
ancestor is grandfather, so that would be 4 is log of that. So log of the distance between you and your ancestor. So binary lifting, you can check, like you can Google it. You probably have.
I'm googling it right now. Yeah, okay. I have seen
the
it.
For article is pretty. That's how I learned about it.
Dude, I was on that page while you were talking, so
Yeah.
I found
Well,
it.
it's the first that Google gives you. So.
Yeah.
So you get the ancestor of every power of 2 of any node, and then you can reconstitute the ancestor, any ancestor of any node, by writing the. Maybe I will try a sample code. But we need a tree, so.
Okay, I'm sorry to like.
Is there a problem like that on Leetcode? Yeah.
It's probably our like to find the cave ancestor of a node. I will assume or something like that. But not to disrupt you. I was just thinking about something. You talked about that you wanted to like live off teaching people Leetcode, right?
Yeah.
Like, do you have a YouTube channel? Like, you can start like just posting like the way you do with me, just explaining some algorithms or whatever, and just start.
Yeah, I have a YouTube channel.
Oh, you have?
It's mostly. Yeah,
A link
you
with
can
the
check it. There are some gaming videos. It's the same name as my Twitch channel, but it's been like 2 years or 3 years since my last video.
I always forget it's 428. I would like always have to search like Yeah, but I was gonna say like it just seems great that like I said, I think you're great at explaining things. So I think it would be awesome if you started creating some videos and just testing it out, since you talked about that was what you wanted.
Yeah, maybe that would be a good idea. Yeah.
Yeah.
But there are already plenty of like if Erito has done the same video as me, explaining the same thing, definitely he will do a better job. So.
Yeah, but to be fair, there are millions of videos of exactly the same topic, and sometimes it's not necessary.
Yeah, that's true.
And sometimes you might capture.
Like when I had a video, I want to be helpful. Like if I want it to be useful, I don't want it to be another like subpar video.
Yeah, totally. Because like I imagine like you could do something like I don't know like what angle you would have, but you can like change it so it's not exactly the way, for instance, Ericto does it. Because like he is awesome too, but I'm like, think of another angle. For instance, like the progression. How would you learn it? Maybe you even talk about your own progression. The 9 months you started since you started competitive programming, and now you're top 1%. Yeah, you're not like top 10
on
or
Leetcode.
something. Yeah, on Leetcode.
On
But still,
Leetcode.
yeah, on Leetcode. But still impressive. Like I think it's like people would be interested in it. Because I've been thinking of like creating my own YouTube, but my YouTube would be more angled towards using a lot of the techniques you teach me specifically for interviews, similar, more similar to Neetcode, but take a more theoretical approach. So yeah, it's like a middle ground between competitive programming and interview style based programming. Yeah, well, I've been thinking of doing that, but I was just saying like, okay, but you should at least do it, because for me it's not that important. But for me, I think that would be suitable for you.
Yeah, doing videos explaining algorithms. I could do that.
Yeah, because isn't that your goal?
Take some problems out of the illustration.
Yeah, because isn't that your goal already?
Oh, thank you. Thank you.
And if you do, please just send me a message and I will watch. I will be your first subscriber. Or if you use the same account or not.
Yeah, why not? Yeah.
Yeah.
So.
And worst case.
Yeah. Read about binary lifting?
Yeah, you can talk about it. I was gonna say worst case is like, yeah, no one cares. That's no shame. That's the worst case.
Yeah, I have videos on my channel that like have 1 or 2 views, so it's not a problem for me.
Yeah, but yeah, back to binary lifting.
Yeah. So with binary lifting, if you see the code snippet values, well, it's mostly what you have to do. You want to do everything. Yeah, that's the formula. The key formula is in bold there. So it's the same as fast exponentiation. You probably have seen fast exponentiation.
I've seen it, but I don't know exactly how it works.
Yeah, it's like x to the 4 is x squared.
X to the 4 x.
X to the 8 is x to the 4 times x to the 4.
Oh yeah. No, okay, yeah.
So you could get every x to the any power of 2 in log n time.
Okay.
Because you will be able to multiply the limit by 2 each new operation. So log operation to that, and that for each node. So like looking for an ancestor is like trying to elevate the node to a given power, and it's not a power, but it's the application, which is well, looking for the dad, and so that function you can compose it many times by itself. So we not composition of function like this, so you can have f square of x, f4 of x. So there f the rule is f of 2n of x is f n of x, and fn of fn of x.
Yeah. Yeah. I see.
So basically, in the code, that would be so let's say you have a tree. N is let's say n is the number of nodes. So worst case, the tree is unbalanced, and you may want to look for the nth ancestor. But you can declare L, which is n.bit length. So L is such that 2 to the L is the smallest power of 2 that is strictly greater than n.
Okay, yeah. So for instance, if
So
I
if
had...
you have everything, yeah.
So for instance,
If
if
you have
I...
every power of 2 up to L, it's okay.
Yeah. So with example, if I wanted n equals 100, would it return 128?
In binary, it is 1, 0.
Yeah.
Well, whatever it is, well, n equals 100. That's just the length of the binary.
Yeah, okay.
So that's why 2 to the 7 is 1 and that number of 0. So
Yeah.
it's strictly greater
And
than...
to the 2 to the power of 7 is 128. So yeah. Yeah, but it makes sense. So great. Because I never seen like bit length, like the function before. That's why I was interested.
So it's like you have to do the for loops in that specific order. If you do it in another order, you don't get the guarantee that every time you use something, you have finished calculating it, which is in any DP, any dynamic programming approach, because this is a specific case of a dynamic programming approach. You want to think about the order in which you compute the values, such that every value that you use in a computation has already been completely calculated and will not be modified anymore.
Yeah, so you essentially do pre-calculations of...
So for every we compute every DAD of every direct ancestor, then every ancestor of so every f of x, every f squared of x, you know, every f
for
x,
yeah,
etc.
and etc. Yeah.
Okay.
And all the way to for f to the power
To
of
s
7.
yeah, f 128.
Yeah. Okay. Yeah.
So like binary lifting will be a matrix where you store, so the initial value doesn't matter.
Okay. Yeah, because you store, you create. Yeah.
So if it's a direct by apparent, we suppose we have all that. We have an access to apparent array or dictionary. And otherwise, well, we just apply the formula. What is f to the j of node? It is f of f 2 to the j minus 1, like f to the j minus 1 of f of node to the j minus.
Yeah.
J minus 1. Well, at least with that function, I don't know what specifics where you can't do that. Well, you can do that with a so more generally speaking, you can binary search in a tree where the function is the relation of parenthood. But you could also be able to binary search with other functions, like with the power itself, of course. which is a convoluted way to do fast exponentiation, but it's easier to do fast exponentiation recursively. But that would be a way to do it iteratively. Okay, and then you have everything, and so now if you want any ancestor, the k ancestor of x, you will look at the bit representation of k. That's one way to do it. So you have like, one one arrow v, which is 0, 0, 1. Well, there is only 1, 1. So if you end with that, you just check if that bit is set in k. So if bit v is set in k, then you want.
What does the one arrow
So you start
v?
where you at. You start at x.
Uh-huh.
What do you mean?
The
What
if
was your
some
question?
the one arrow v. What does this mean?
Oh, it's left shift. So like.
Okay. Equals what? Yeah.
In binary, huh? In binary. So this is 8. This is actually power of 2. 2.
Okay.
So equivalent to 1 flash v is.
Yeah, now I understand.
Yeah, okay.
Thank you.
Yeah. Okay, and then results you update it like that, and at the end, like it's magic. Result will be the Kate ancestor. They have a nice drawing on the Geeks for Geeks page.
Okay.
To understand how that works. Because, for example, for 100 we have that. So what this will do is, so we will take the 64th. So we will have x at first, then we'll compose it 64 times. So we will have that. But then we will have 64 plus. So you see. But we can actually write it in only one application, and just we add the exponents. So at the end, if we, so this is to say that 100, another way to say it is that 100 is 64 plus 2 plus 4, yes, yeah. And so what we will compute is well, the way I do it, it's reversed, but it doesn't matter because addition can go both ways.
Yeah.
Addition, associative and commutative. And so another way to write it is just.
Oh, that's wonderful. Yeah, I see it.
Yeah. So you actually have the ancestor of X, this 100th ancestor of X. And there is a actually, if you look at the Wikipedia page about fast exponentiation, this is how they explain fast exponentiation. So that would be the iterative way of explaining the explication. The recursive way of doing it is.
Oh, that's clean.
So that's the recursive way, and so that's actually something radical. Yeah. So that was how I was explained fast exponentiation, but you can also do it like that, computing every power of 2, then decomposing whatever you want in binary and taking the adequate ancestor every time. So at the end, you have the ancestor that you actually want. Yeah, so basically now if we have all the relevant structures, if we have parent, if we have a tree, yeah, this function will return the kth ancestor. Can try to. There is if you want to, I can give you a problem using binary lifting if you want.
I don't think
So
I'm
you can
ready for it right now, but you can send
Okay.
me. I can try.
Okay. Also, there is something I did not explain. Okay, very important. Okay, let's say. Okay, it will be easier to explain if I draw this thing. So you have a tree.
Uh-huh.
And with binary lifting, we are able to get any ancestor of any node, but we can get even more than that. Like, well, let's say every edge has weights. You can, for example, get the sum of weights between you and the ancestor that you got, you know?
Okay.
So you can maintain that. That's you can maintain the sum between you and your ancestor. Like when you do the first part, that one, you will instead of having just parent of so instead
Yeah,
of storing just
just
the value of
parent.
the
You
parent,
also
you store the value of the parent and
also
the
the
sum
weight.
between.
Okay, yeah.
Yeah, okay. Val, and then when you do that, so you get the parent of that one, j minus 1 parent of that one, but also the second value will be you can have you will have to define kind of a merge function between so the value between you and that one. And there is also the value between you and that one. And knowing v2 and v1, if you have a way to merge them, if it's the sum, merge will be simply the plus operator. For more complex operation, you have to think how you can, knowing that and that, or you can know that v3. So basically, there the value between so that's what we can call v1, and then v2 will be no v2 will be that one. So of that node, okay. If we have everything, yeah, because every j minus 1, so notice, very important, that we want the for j loop first, because in the computation we read, you always look at what is read. So what is read there, so what we need to read to get our results, you only have j minus 1 in there. So everything with j minus 1, you have it. You have already computed it.
Yeah.
Because you're doing the loop in that order. If we were to do the loop in the other order, it would not work. because we don't know if we have j-1 of that node. Yeah, we have every j-1, so at the time we want j, we can compute it. Yeah, so that's kind of hard to read, I know. But
Yeah.
basically, so that's why I wanted to draw it, because it's simpler when you draw it, but that's one of the cases when to write it. So, yeah, I did it in one line, but you can like define variable v1 is. So that corresponds to that. V2 is. So now we get the answer. So intermediate ancestor, intermediate.
Yeah, and just
You know, and so it's intermediate of. So intermediate of 0 is the actual node, intermediate node, and of 1 it's what links that intermediate node to this. So it's v2. I think. Yeah. Yeah. Oh, yeah, yeah, that of j minus. Okay. Oh, so it's not really. Yeah, how can I say that? Yeah, it's more. I don't know. The intermediate is not I9. V2. To correspond to the drawing.
yeah.
And so now you can maintain any such value that is mergeable. So mergeable means there exists an homomorphism where, okay, in the first set, it's the composition of two functions, and then in the second set, it's the merge of two values.
Yeah.
So as long as you can define such an homomorphism, you're able to solve many problems with that. For some, you don't actually need this technique, because you can also do the prefix sum on the tree, going to the root to any node. Like if you know the sum between that, and if you know the sum between that, in a prefixtion way, you can subtract those two, and you know. But for some operations, I think you have to do that. And the nice thing is it is done as part of the binary lifting loop. So you can have everything in one block. Okay. Yeah, so that basically is it. I can give you a problem which is, well, actually the problem I gave you is actually pretty hard.
Okay.
It's rated on zero track, it's on the second page. I told you about zero track.
Yeah, I
right?
have it.
Yeah. So it's like the 20th hardest question on Leetcode.
Okay, please don't do that to me.
According to them, I don't think it's that hard, because I think just many people don't know about binary lifting. But once you know about binary lifting, and specifically that twist with the homomorphism, like what I explained at the end, maybe you have also weapons to solve this problem. Okay, any question?
I think I understood it. The only issue I have is it's not a question. It's more like I'm uncertain that I will be able to recreate it.
To recreate this, yeah, you can just actually my template. I got it from the web page, so I think they have a pseudocode or a code in the web page. You can just try to. First time I did it, I just copied the source code, and then out of habit, I I could do it myself.
I didn't know you
What
could do it.
happened?
I didn't know you could do this in
Oh,
Discord.
you used the Discord. Oh yeah, I see.
I never done this before, so like, what the fuck is this?
Hmm.
But yeah,
Oh, but it's weird because I swear that on the last time I looked at this page, they had a code for it. And a cleaner one than what I see there. Oh. Yeah, the C++ CBP code looks better. No, it's actually the same. Oh, yeah, something very important when you try to do binary lifting. You want the root to... the parent of the root is the root itself.
the parent of the root is the root itself.
Yeah, because
Okay.
otherwise what will happen is you may go out of bounds.
Ah.
So if the parent of the root is the root itself, you will loop on the root. Like let's say I am requesting the third ancestor of 2. Well, the first ancestor of 2 is the root. And then if I don't have that this self loop, well, this is just going to mess things up. Where, like, either it will point to nowhere, or I made it point to an arbitrary value, but it is not what I want. I just want it to stay there. So when I request to, when I overshoot my request, it actually will return me the root because it will loop on the root.
Yeah, I understand. So you need to ensure that's the case.
Yeah. If it is not in the problem already, you add you add that edge from the root to itself.
Yeah. May I ask, like, how often do you think these questions appear?
Binary lifting. Let me think. So there is that problem on Leetcode. I have seen one problem the first time I had to use it. Actually, it was on code forces. You can use it to find the least common ancestor. Well, that's something that's a non-trivial use of it actually, because it's kind of binary search with where you binary search for how high you want to choose your ancestor, so it's still in it could still be a common ancestor that you know, so it's used in that case.
I like.
I may have seen it in two or three other problems that I don't recall, but yeah, it's pretty rare. So in total, 4 or 5 problems among all the problems that I've seen.
I like that you said non-trivial. I thought you had purged trivial from your vocabulary.
Oh no, non-trivial is a word in itself, and I have not purged
That's true. That's true.
I said non-trivial.
Okay. I'll let it go. You're correct.
You can find it on CPL. I will link it. CPL algorithm FCA. Well, that one I have never used, but yeah, it's a use of binary lifting. So as long as we're explaining binary lifting.
Yeah, I actually looked at that one.
Oh, okay.
Because it was linked from the Geek for Geeks page.
Can give you, well, if I give you the problems where you use binary lifting, it's a kind of a spoil because you will know that you have to use binary lifting. So I don't
Exactly.
know.
So
Yeah.
I think, at least for now, before I get more better at competitive programming, I think it's good enough that I know about it. So like I now know the existence of it, and if I suddenly see something where I can use it, I will just Google it and figure out how to do it.
Yeah.
I think that's like the best, because like I see this is too advanced for me to like really learn, like really understand it, because I'm still like struggling with depth first search and breadth first search, so I don't think this is like where I should start.
Well, you have seen the code. It's pretty.
Yeah, it's
It's like well,
it's straightforward
and
and
that's
pretty.
the most extensive version of it, where you have the merge thing and all.
Okay, okay, but that's actually nice to hear. But I like the eloquence of it. It's like really beautiful, if that makes sense. It's like clean. It's just like so simple yet so advanced, if that makes sense.
Yeah. That's that's the same thing with Union Find. It's also a very simple. Oh, Union Find, yeah. I can code it like by heart, and it's very easy. It's like Union. Oh, I've tried a Union Find, I think, in the last weekly, but it didn't work. Yeah, but so Union Find is just those two functions.
Yeah, because I was just
But
gonna ask like
now,
I was just gonna ask what does find do? You defined it, so I was like, oh yeah, okay, that makes
yeah, you
sense.
can define it after, and it works in Python.
Nah,
Just
I know it works. I was just like while you were right, like, oh, is find a function I need to learn now, but yeah, it's just
Mm.
it's your own function.
Yeah. So actually, if the find of the two is the same, the union is just doing nothing, so we can just return, and we return false to. That's how I do it, to have the
Mm-hmm.
information that we tried to union something where it was actually in the same connected component. Because union find is you want to keep, you want to work with connected components, and you want to maintain a leader of each connected component. I don't know what's the right term for it. In French, we say a representative, but I don't know if we say a representative of a connected component in every language, you know,
Yeah,
because for every connected component.
that's some technical
Oh,
words I don't know.
well, no, actually, it's used when you talk about equivalence class, but a connected component is a specific, it's also an equivalent class.
Okay.
So we can use that theory.
I
So we merge equivalent classes with union, and we find the representative of a given of the representative of X. So of the class in which X belongs, or class or connected component, because connected component is a specific kind of equivalence class. So well, the Wikipedia page is actually pretty useful for union find. It explains everything. You may check that.
okay. I will look more into Union Find because like I think I
Yeah, union
isn't
find is more common than binary lifting.
yeah
You use
because
it
Union Find I feel
more.
like I actually have known before. Like it
Oh,
wasn't like um completely like difficult for me to like I think I've seen it. Yeah, it's the same as
honestly,
disjoint
I can make.
set.
Okay, so you have elements, and some elements are merged and they are considered equivalents. They belong to the same equivalence class.
Yeah.
So those two. And so the equivalence class are disjoint,
Mm-hmm.
because if they were not, then it would just be one equivalence class, because of the transitivity of the relation. Then if that was not disjoint, then everything would be equivalent, and this would just be one big
Yeah.
equivalent class. So they are disjoint by definition, and you want to be able to merge them.
Yeah.
So
Okay.
there can also be an equivalence class containing a single element. Let's say this one contains three elements. Okay, and like it's like slimes, and you want to merge the slimes, so you get a bigger slimes with 5 elements there. So how do you do that? So internally you have a tree where each at first at first when you start from a blank slate, so when everything is in its own equivalence class. So your tree is like it's a forest actually. So you have a forest here. More, not a tree but a forest where every tree is just the root. And then you merge the root of the two trees. So find is just find the root, and merge is merge the two roots. So let's say we want to union those two. So now we will have that, and that tree is the union of those two trees. Let's say we also want to union that one with that one. So we would have etc. And find is you. Okay, so but there you don't see the edge case where we have a tree with an 8 that is more than 1, because that can also happen. Yeah, okay, so let's say that now we are looking at this one and we want to merge its tree with that tree. So what we will have, so we have that, okay. And yeah, you can then have a case where by doing merge in a specific order, you get a tree that looks like this, that is unbalanced, that is a linked list, and that's bad because if you want to find the roots, you don't want to go up so many steps. So every time you call find, you actually redesign the tree. So let's say, okay, we are in that state, and our tree is that. So our 4 elements are in the same connected component, and it's schematized like this. When we call find on that element, what it will do, because we have that line, if the dad, so its direct dad is not itself, because, okay, so yeah, also every root points to itself. So there it doesn't point to itself. So we also can call find on this, where it doesn't point to itself, where it points to itself. So we can just return that. And so we redirect the tree. What happens actually is that this gets transformed into, so every node becomes the direct child of the root. Well, every node on the lineage of the node on which we called it. So to be more, like maybe it's more illustrative, if we call it on, let's say that one, we'll make it so that each of these nodes, its dad, its granddad, etc., are direct child of the roots. So at the end, we call find on the last node, well, on that node which is very deep, and every node in when going up will become a direct child. So there, everything will be a direct child of the root. See. But if it, but let's say that we had another branch like that. So yeah, at the end, that other branch will not change, but our branch will be deconstructed and everything will be direct child of the root, which is good because for subsequent find calls, we will only have to go one step. So that allows for a very fast time complexity.
Yeah.
Which is actually it's the inverse function of the Ackermann function, so it's almost constant time. Very, very.
Really?
It's a function that increases very, very slowly. Yeah.
Okay, I assume it would be slightly higher, but okay. Just like a quick.
Yeah, because you don't let that happen. Actually, the tree will not look like that because of the rank heuristic. Well, you can.
Yeah, but just a quick thing. I think I will end my stream now, but we can talk more on Discord. I just
Okay.
So yeah, to those few watching the stream, I'll end it now. Thanks for today. I probably won't stream later because I'm really tired today.